Hello guys, I am Mansoor. Welcome to our YouTube channel, The Keras Bridge. Today we will be seeing about what is dropout technique in neural network. So in our previous sessions, we covered what is activation functions, what are the different types of activation functions and their explanation and math intuition behind it. As well, we have completed our optimizers videos as well. What are the different types of optimizers we have, and we have also covered what is transfer learning technique also, right? So today we will be seeing about what is dropout technique. So why dropout technique is required in a neural networks, right? So normally this is our this is something our neural network. This is how it will be looking. Okay, so I told you, right, there will be input layers. This will be the output layer. So this will be the input layers and this will be the output layers, right? So in this case, what happened? All the neurons are connected with each other, and at the last we will be finding the output or the predicted value. Okay, so while performing this, so normally we have three different kinds of neural network, right? ANN, CNN and RNN. Okay, so when we are performing ANN, CNN or RNN, so the basic thing is we need to input with the test data. So what happened when we are working with a large number of huge neural network with multiple hidden layers with a small amount of data? Just consider we have something around 36 hidden layers. Okay, we have 36 hidden layers. We are doing some CNN problem. Okay, we are trying to do an object detection technique. Okay, in object detection we are sending some object like apple and orange, so our model needs to identify whether it is an apple or orange. In that case we have 36 hidden layers and we are using only some 500 sets of data. Okay, so when we are doing this thing, when our neural network is very high in the sense a huge neural network, and we are like inputting with training or testing with our what is that training with our very low data set or very a small amount of data set, we come to a problem which is known as overfitting. Okay, come to a problem which is known as overfitting. To overcome this overfitting problem, we found a technique which is known as dropout technique. So this dropout technique was found out by godfather of AI. We all know him. Um, so Jeffrey Hinton. So this is the person. So you guys already, I think you know about him. I have already discussed about him in a previous, like long back ago. So he is known as a godfather of AI or artificial intelligence. Okay, so he have published a paper on dropout and overfitting method. So this is the complete paper. If you want, you can just go through this paper. I will be giving this link in the description. Okay, if you just go through this complete research paper, right, then you don't need to like refer any videos or don't need to refer any blog, because this is that much sufficient enough to understand why dropout is needed, what happened without dropout and what happened with dropout, and many things. Okay, so even I learned myself by using this research paper. I will be giving this link in the description window. Okay, let's come back to our video. So now we know what is the problem when we are using a small amount of data set to a large number of neural network. So how to overcome this? To overcome, we have a technique known as dropout. So in the name itself, we can able to find it. We are like leaving or dropping some data. Okay, if we just go down, sorry. So here we can see, right? If you compare these two neural network, here all the neurons are connected with each other, but here if you see, some neurons are connected, some are disconnected. This disconnecting technique is known as dropout. It's nothing but what we will be doing is, so see, in this case, this neuron and this neuron this neuron and this neuron are disconnected. Here this is disconnected, here these two are disconnected. That means while training our neural network, right, we will be dropping out some layers. It may be, so how many layers we have? We have input layer, we have hidden layer, we have output layer. In hidden layer itself, we will be like having, what is that, many layers, like fully connected dense layer, convolutional layer, and we will be having max pooling layer. So we have n number of layers. So the only thing is we can use this dropout in all the layers except the hidden layer, sorry, output layer. Okay, so let me try to explain you. See how the neural network will be trained. Neural network will be trained in forward, and then weights will be updated in backwards. By using optimizers and activation functions, we will be reducing the loss function, right? So in this technique, what happened, we have something known as p-value. This p-value is nothing but it will be ranges from 0 less than or equal to 1. Okay, this will be the range of p-value, which is nothing but if p-value is 0, that means dropout, there will be no dropout layer if p is equal to 0. Okay, if p is greater than 0, that means we have a dropout layer. So that means we are dropping some layers in it. Okay, so that's why we describe p value between 0 and 1. Okay, now what happened, as per the paper which published by Mr. Hinton, right? So how we used to find this is the p value, which is the probability value, which is the, like, there will be n number of values, zero stay starting from 0.1 to 0.999. We have n number of values between this, right? So between these two like between the range of 0 to 1, which is considered as a most like efficient value. So the value between 0.5 to 0.8 is considered as the most efficient value of the p-value when we are using a dropout technique. So I will explain you why it is considered as a most efficient value. Because just consider, in this particular this thing, right, we have 1 2 3 4 5, we have 5 neurons. Okay, if our p-value is 0.5, it will be dropping out 50 percentage of the nodes, and 50 percentage will be considered. That means 50 percentage will be left over, 50 percentage will be considered. So that is excuse me, that is known as the p-value. Okay, so now as I told before, right, we will be um, like, to calculate the loss or to train a neural network, we will be traversing in front and back propagation. So what happened, see, when we are traversing in front, this layer is connected to this thing, and this is connected to this, and this is connected to this. So this is okay in traversing in a forward direction. That means we have not connected to this layer and this layer, we have only connected to these two layers from the first node. Okay, but when we are back propagating, how to update weights? Because when we back propagating, we need to update weights to each and every nodes which is connected, right? The same way, see, when now this neuron in forward propagation is connected to this here, and it will be going here. Okay, so now in back propagation, how it will be happening? In back propagation, right, from here it will be going here, same path, again it will be going here, and it will be going here. Okay, and to this node, how it will be going? It will be going here, here, and it will be going to this node. Okay, like this it will be traversing. So the path which goes in forward direction, right, in feed forward direction, same path, the weights are updated in back propagation also. It's nothing but the weights which we update in a back propagation will applies to only the active layers. So let me write you over here. So after applying the dropout, we have two layers, right? Drop layer, active layer. Okay, we have two layers, drop layer and active layer. So let me rub this. if you consider in this particular node, in this particular layer, we have 3 active layers and we have 2 hidden, what is the drop layer. Okay, so in back propagation, what happens, how the weight will be updated? So the weight will be updated to only this 3 nodes, these 2 nodes, which is sorry, 2 neurons which is deactivated will be not getting updated. Okay, this is the technique behind dropout. So why we use this dropout? To avoid the problem of overfitting when we have a huge neural network and when we train a data with a small amount of data. Okay, and this will maximally reduce the overfitting problem. And one more thing, what is, so when to use this dropout technique? We know, right, with the p-value should be greater than or equal to 0 and 1, and the like best fit p-value is 0.528. But when to use this dropout technique? This dropout technique should be used only in trained data set. Okay, the dropout technique should be used only in the trained data set. In test data set, what we will be doing is, because in test data set, this we have something known as p-value, right? In the test, so how we will be calculating our thing? So the formula behind which is I is equal to 1 to n xi into wi. This is the like activation function formula, right? So in this thing, what we will be doing with this function, we will be just multiplying our p-value also. So we will be just multiplying with this p-value for the test data. Okay, so like just remember this, the dropout will be only applicable for the trained data. In test data, we will be not doing any dropout techniques. So why we need to do the dropout in only in test data? Because while training our data only, we used to get this overfitting problem, right? So if we get overfitting problem, if we test with our test data, we will be not get that accurate output or the maximum number of what is that accuracy. So we will be going in a, so our loss function will be very high. To overcoming that, we are using dropout. That's why we need to only use this what is this dropout in the training data. Okay, so I think now it is clear. I hope like you guys understood what is dropout, why we used to like implement dropout in our neural network. To avoid overfitting, we will be using dropout. Okay, and we know, right, how to like find the p-value. P-value should be range between 0 to, let me dump this. So p-value should be ranging between 0 to 1. Okay, the best fit p-value is between 0.5 to 0.8. Okay, so if you have any queries, if you have any doubts, please let me know in comment section. I will be replying to you, and I will be giving this what is this, the paper which is which is like submitted by Jeffrey Hinton. Okay, you guys can refer this as well. So in our next session, we will be starting with our initial artificial neural network. Okay, so I think the theory part is almost completed. So we'll be starting with the practical session with artificial neural network. So we'll be creating a single layer, and then we will be like going with the multiple layer, dense layer, and fully connected layers. So please stay with us. If you like this video, kindly hit on the like button, and if you haven't subscribed to our channel, please do subscribe and share with your friends who is interested in learning with deep learning techniques. So let us meet in the next video. Until then, thank you. Bye bye.